All right, so let's take a look here at ionic radius. So ionic radius addresses what happens when an atom becomes an ion, and you may remember from previous chapters that cations are atoms that lose electrons. An atom like calcium would lose its electrons to become calcium 2 plus. The two it loses are in the fourth energy level, these two electrons here, and as a result it has 18 electrons like the noble gas argon. So it has a stable electron configuration. It has its 20 protons still. That's what makes calcium calcium, is the existence of 20 protons. So by losing these electrons, it actually becomes smaller. The electrons have more attraction toward the center. There are more protons than electrons now, so there's more attraction. And the atomic radius, the distance from this nucleus to the outermost electron, would become less for calcium 2 plus versus calcium. It became smaller. For anions, similar argument basically. We have for chlorine 17 protons, 17 electrons in 3 energy levels. Anions, you may remember, gain electrons. It gains 1 electron to again become like the argon noble gas configuration. It now has 18 electrons, but chlorine being chlorine still has 17 protons, and 17 protons cannot handle 18 electrons as well as 17 protons, as well as 17 electrons. So the atomic radius, the distance from the nucleus to the outermost shell, becomes a little bigger because it can't draw those in as well. Here's a little musical accompaniment to bring that up. So basically, chlorine cannot hold what it's taking advantage of here. And I will fade out Macklemore. All right, so overall, so let's take a look at the comparison here. We have calcium 2 plus and chlorine minus all end up looking kind of like argon. However, because of the number of protons, they differ in ionic radius. Calcium will have a shortest ionic radius from the nucleus to the outermost electrons because there are more protons drawing them in. Argon would be sort of in the middle. It's doing the best it can with 18 protons and 18 electrons, whereas chlorine has 18 electrons trying to be brought in by 17 protons, so that's actually bigger than argon, argon being bigger than calcium. The end lesson for all this is, as you can see here, here are ionic radiuses where this is the ion Li+, this is lithium, beryllium 2 plus would be the pink, beryllium without a charge would be the gray, and here the oxygen without a charge is the gray, but the oxygen with a 2 minus charge would be the blue. So the point here is when you lose electrons, like here in the metal groups, they become smaller, correct? Lithium becomes smaller when it becomes lithium plus. Sodium becomes smaller. Potassium becomes smaller when it gets a charge, and that's because it's losing 1 electron, it's keeping all its protons, and it draws those electrons in a little more. Whereas anions gain electrons, become larger. Oxygen picks up 2 electrons to become like the noble gas neon. In doing so, it still has the 8 protons trying to draw in those 10 electrons, so it becomes bigger as an anion. Fluorine becomes bigger as an anion. Chlorine becomes bigger as an anion. Sulfur becomes bigger as an anion. Something else to sort of notice here. So sodium and magnesium both have the same noble gas configuration, but because magnesium has the extra proton versus sodium, it actually does get a little smaller than sodium. Same thing with beryllium, gets smaller than lithium. Calcium gets smaller than potassium by having more protons than electrons in the center. It can draw those in, and the opposite is true here, where having an extra electron will make selenium 2 minus bigger than bromine minus. Sulfur 2 minus will be bigger than chlorine minus. Minor point, you don't have to worry about that as much. And that covers periodic trends.